All right, everybody, welcome. I want to thank Eastbanc Technologies for hosting us. This is the start of a series of events we're going to be doing with Eastbanc. They've been a great partner of ours and continue to be. And so thanks for coming out here to Georgetown. Hopefully you found it okay. Anyway, with that said, I'm going to turn it over to Vlad to get our presentation going. Let's give a warm welcome.
All right, my name is Vladimir. Vlad. So I hope you guys are going to enjoy the presentation. If you don't, I don't need to know about this. But I know that you had your pizza and your beer, so you might get sleepy. But I'm trying to, keep you guys upbeat. And just little teaser, we have a special fun segment at the very end of the presentation. So just stay tuned, all right? And so the technology we're going to talk today is actually taking the world by storm. Before the conventional, before like 5-10 years ago, the common business model was basically collect the data for like months, weeks, and then process to some point and generate some, analytical report that, you send to executive and they read it and then you make some adjustments to your business. Well, this is actually not working anymore because the world is just flooding with the data. It gets flooded. I think the report is that we generate like 5 petabyte of data like every year, every year or every day. So there is just an enormous amount of information that's flowing into your business, and that's you have to find new ways to process this data. And before we actually start talking about some of the technical things, and I need to turn my clicker. There you go. Let's put some definition in place. So when we talk about processing streaming data, what is streaming data? So what it's not like streaming video or streaming music. So it's basically a data that gets generated by a business application or by some devices or telemetry information that flows into your business, and then you have to make some analysis on this data and then do some actions, right? So the data at rest, this is a conventional approach. Basically, the example over here is that the company is making analysis of last month's sales information, right? So the data was collected, during several weeks before we do the analysis, and at some point, the people in the dark room, run some ETL job, aggregate some several data sources, and produce a report. Like then you send this report to the executives, they read it, and then make some strategic decision about what they're going to do next, and maybe they increase maybe they do some marketing activities, maybe they increase some stocks, things like this. So another example is when you process the data in motion. So this is an example. Let's say you have people, guest to the theme park, right? And each guest in the theme park is going to have some kind of like a bracelet that's going to have a RFID. And each time the guest walks through the ride, right, the RFID reads the ID of the guest and sends it to some data center. Then in data center we can process this data at the runtime and make some actionable things to improve the user's experience at the park while the user is still there in the park. And we have a better chance to actually generate more business right there. Make sense? And so here are some of the use cases for the processing streaming data. All the automotive smart cars. They basically just around the corner. They're coming, and so the amount of data these cars generate is just enormous, right? So basically every second, hundreds of sensors in the car generate some metrics, and the car has to process this, or maybe just sends it somewhere, and then the cloud processor processes it. Another thing is, the medical vital signs and fitness trackers. This is also a great opportunity to make some real-time processing and generate some useful information there. Weather reports and environmental data application, the generated instrumentation and telemetry data, home automation, And last but not least, some farming. You can, put the sensors on different crops and monitor how they grow. And actually, let's talk about the last one. How about connected cow? So I saw this slide when Microsoft was doing the announcement of HD Inside, which is a hosted version of Hadoop in Azure, right? And so some executive went on stage and said that Microsoft actually partnered with the scientists at Fujitsu, and they were tasked by the dairy farmers of the United States to improve outcome of artificial insemination. And so how do you do this, right? How do you apply technology to, and the joke was basically the one AI meets AI, which is the different kinds of AI, artificial insemination and artificial intelligence, right? And so, you can go the route, the usual conventional route. Like you can take the blood samples from the, hundreds of or thousands of cars and your cattle, right? But it's kind of, expensive. You have to provide particular conditions. But well, actually, what scientists came up with is they basically just put pedometers on the cows, just regular pedometers. Most people, wear Fitbits, but they were counting for how many steps the cow did, and it happens to be a very known phenomena. So when the cow approaches estrus, it kind of gets restless, and it's instead of going to sleep in the evening in the stall, it just kind of keeps walking around, and the pedometer keeps counting steps, right? And so when this happens, you see the green line is average on how many steps the cow does on the average day, and when it approaches estrus, there is a several times difference there, right? So it's very easily detectable, and basically from this point on, you have 24 hours to do the artificial insemination. Interesting fact, by the way. So they also came up with some of the results analyzing the data post experiments, and so if you do the AI in the first 16 hours, you have a 75% chance of a female cow. Yeah, and if it's past the 16 hours, a 70% chance of a male cow. So another great benefit of doing some science like this. And I'm talking about this not because I suggest you all go to the business of artificial insemination, but I think this is a great example when the new technology combined with some some unconventional knowledge can produce great results, right? So the benefit of your customers. And so let's take a look about some of the end-to-end architectural solutions that basically designed to process the streaming data. So it all starts with some kind of devices or sensors that we call event producers. So basically, you produce those events. Your applications or devices produce those events, and some of those devices are really not that powerful to send the data straight to the cloud, and so you're going to end up having what's called local gateways. And so the device is going to send information to the gateways, and then the gateway is going to pass it on to the cloud. And somewhere in the cloud, you're going to have some kind of a collection service. So essentially, it's all ends up some kind of a queue. We're going to take a look at the offering in Microsoft Azure, which is called Event Hubs. And this is a very, very cool designed for the cloud data ingest service that can accommodate hundreds of thousands and millions of devices sending data simultaneously into the cloud. After you collected your data, you basically so think about this as some kind of a buffer, right? So you just keep throwing the data into some kind of a big funnel, and then on the other end of the funnel, you have some kind of a process that transforms the data, right? So that does some aggregation maybe, and does some analytics, looking for the patterns and see if there's any event that we would like to act on, right? And so the data, once the data gets processed, it essentially gets stored in some kind of a storage, right? And there's actually in the big data world, when we talk about storing the data, there's usually saying there's two ways to store the data. There's a cold path and a hot path. So the The call process, you basically just take the data straight and save it some kind of like a blob storage or database, but database usually not working that good for this kind of data, amounts of data. There's also options to send the data to the Azure DBs, the HDFS and HBase. If you use another system that Microsoft actually hosting is called Apache Storm. This is a much more advanced. Stream processing system, and it has greater capabilities than Azure Stream Analytics. But Azure Stream Analytic is very approachable. I think every one of you here, if you've done some SQL database programming, you can easily start, writing those Stream Analytic jobs today, because what Microsoft did is they took the SQL language that we all know and love, right, to work on the SQL data, and they modified it with some features that tailored specifically to processing the streaming data. So the data can be stored in the database. One can be passed to some kind of dashboard for the presentation purposes. So you can either write a custom dashboard, or you can use, it's actually not here, you can use a Power BI. Microsoft is very heavy of introducing the Power BI in different facets of the business, and so you can use a Power BI dashboard to kind of visualize your data. And one item over here, you can actually extract some insight, we call actionable insight, and send information back to the device to take some action, right? And we're actually going to do some demo at the very end when we're going to try to play this scenario. So we talked about overall architecture. Now let's talk about every component of this piece, right? So for the purposes of today's presentation, we're going to generate basically the data from the thermal sensor that's connected to the Raspberry Pi. That's right there in the middle of the conference table. I actually have a couple more sensors. I have one at my home, and I have one at the third floor. And so we're going to try to collect the data from those Raspberry Pis. And who doesn't know what Raspberry Pi is? I think I don't need to explain, right? So everybody knows. So we're just going to move on. And so you read the data you generate the data from the Raspberry Pi, and you send it to the Event Hub. Event Hub is a part of Microsoft Azure Service Bus. And Service Bus is kind of family of services that's designed to work with event data, right, if you will. So the very first service, actually, there was a member of the service bus, is called Relay, Azure Service Bus Relay. And this is the service that's designed to traverse the on-premise boundaries. So let's say you have a service that you run on-premise, right? And you want people from other parts of the world use. So how do you do this without actually poking your firewall or your network infrastructure? Well, it happens that you can actually create a listener in the cloud using Azure Service Bus Relay, and it's going to use some magic behind the scene, and it's going to expose your service in a secure way in the cloud that people from all around the world can connect and then use your on-premise service. So it's a really, really nice technology, and I think it was very ahead of its time when it just released, like 10 years ago or something. So the second one is classical queues. It's basically your reliable brokered messaging technology. So designed to you have multiple event producers, right, sending the messages into the queue, and then you have single consumer. You can have multiple consumers, but then you have to think about that. Once you read the message from the queue, it's not going to be available to other consumers, right? So essentially, it's usually done in scenarios when you want to do some kind of a load leveling. So you have lots of different parties sending the messages, and then some single party reading the messages from the queue. Topics is very similar to the queue, but instead of having a single consumer on the reading side, you can basically fan out your messages into the subscriptions, and then different parties can subscribe create a listeners to your subscriptions and read the same messages across your service. Notification Hub is it's basically a distribution service designed for hyperscale notification distribution. And think about you have your application that sends notification messages to the push notifications to the cell phones, right? And it supports hundreds and hundreds of thousands of devices to push the data out. And finally, the Event Hub. And that's what we want to talk a little more today. So Azure Event Hub is designed for hyperscale. It's a fully managed service in the cloud. It's designed to be interoperable and secure, and it's very, very cost effective. So if you want to compare to some other services, I think there's actually Amazon. Amazon has now some similar technologies. I don't remember the name. I think it's Kinesis.
Yeah.
Kinesis. And but if you want to implement it your own service, it's going to cost you much more. I think right now you can host a very simple event hub for less than $10 for months. I mean, there's some limitations on the bandwidth and the traffic, but essentially the service itself costs very affordable amount of money. And so you will have multiple hundreds and thousands of devices basically throwing the data into the event hub, and the event hub is going to hold this data for some retention period, and the retention period is a configurable parameter. I mean, it starts usually from 1 day and goes up to, let's say, a week, and you can request more if you need, but it's going to be basically custom request to Microsoft, but they're pretty good at accommodating those kind of requests. And then on the other side, you can have things called consumer groups, and the consumer groups think it's like a pointers in your bucket of data, right? And each application is going to have its consumer group, and it's going to keep reading at the rate that its application basically designed, and another application is going to also read at its own pace. And so they might read at different paces, but essentially they go through the same data. And this is a big difference from the regular queues. When you basically read the message from the queue, it disappears. In Event Hub, it stays there. It stays there until the expiration goes by and the event basically gets expired. So because it's a part of the Azure Service Bus, they use the same partitioned storage to store the events. Excuse me. And the number of the partitions you can request from the portal right now is limited to 32, but again you can request more if you need to. And there are some interesting articles on the internet on how you define the number of the partitions do you need to handle your data load. But for example, in example that we're going to show today, I'm just use a single partition for all the messages for a single device. Let's say I have a single Raspberry Pi here on the table. There's going to be one partition. Another Raspberry Pi is going to be another partition. But when you send the messages into the Event Hub, there's two ways of specifying how do you want to handle the partitioning. You can just send it basically and say, hey, this is the event. I don't care where you place it, and you figure it out. And the Event Hub is basically going to do the round robin on your partitions and place it somewhere, right? Or you can provide a partition key. Partition key is not the same as a partition ID. It's basically a parameter to the hash function that when it passes through the hash function gets resolved in the partition ID. So this way you can basically guarantee that events from the same with the same partition key are going to end up in the same partition. But there's more than one device that's going to send events to the same partition, right? Because it's a part of the Azure Service Bus, it also has the scaling unit called throughput units, and you set this parameter on a namespace. So when you create Event Hub, you always create it on a Service Bus namespace, and by scaling the number of the throughput units on the namespace, you scale the throughput of the Event Hub. And the one throughput unit basically resolves into the up to 1 megabyte per second for the writes and up to 2 megabytes per second for the reads on the other side. Right? Now let's talk about reading. So I already said that you use concept of the consumer groups. You basically can have multiple consumer groups, and each application going to sign up for each particular consumer groups and read the data as it see fit. And in terms of interoperability, the Event Hub support HTTPS protocol, and also they support EMQP1 protocol, which is binary protocol, which is more efficient, and that's what Microsoft suggests to use if you have ability to use it, use MQP. In our own application, we're going to use Event Processor Host, which is a Microsoft SDK implementation of the class that handles multi-threaded reading from the Event Hub, so that you don't have to write this multi-threaded logic yourself and get yourself with all the stuff. So all you have to do is basically you have to instantiate the Event Processor Host class, which is again part of the SDK, and then you call the register Event Processor, which is you pass in the parameter of the class that implements the Event Processor interface. And we're going to take a look, and I think this is actually a demo time. So in this demo, we're going to do three things basically. We're going to create Event Hub, and we're going to create a simple console application that's going to read events from this Event Hub. And the third thing is we're actually going to start sending the events from the Raspberry Pi into this Event Hub, and we're going to see if we get some readings in our console application. So we're going to go to the Microsoft portal, and by the way, the Events Hub is still in the old portal. So that's one of the few things that have not been yet ported to the new one. The Stream Analytics actually mostly in the new portal, except for the some features I'm going to talk a little bit later, but Event Hubs are still, you can start creating the Event Hub from the new portal, but it's just going to show you this link with the error, and then it's going to send you back to the, So we're going to go to the service bus area on the portal, and we're going to navigate. I already have a namespace for this meetup that I created actually couple Event Hubs. But what you actually do is you say create, and we're going to create a new Event Hub. And let's call it MoDev Live Event Hub. We're going to create it in the East US region, and that's going to be in this namespace that I created for this meetup. And this is a partition count. So I'm just going to set 2 because I guess we only have 2 devices. I mean, you don't have to go crazy, right? And it's going to save me some money on my Azure credits that I use for this particular project. And the retention period is by default just 1 day. And there you go. So the system is going to take probably like 5 seconds and create the Event Hub. And if you go to the configure portion of the website, you see we can create some shared access policies. So this is how you define those security credentials for your applications, either consuming or the sending applications. So we're going to create two access policies. So the first one we're going to call sender, and this is one is going to be used by our Raspberry Pi script to send the data. And the second one we're going to call receiver, and we're going to send listen permission, and we're going to save it.
Sounds like it's raining. It's pouring.
Yes. So another thing I'm going to do is I'm going to go to the consumer groups, and I'm going to create the console reader consumer group. So that our application will have its own consumer group to read the data. Now, these are the keys for the policies. I just created 2 policies, and do you guys see all right, or do you have to use them? Okay, I can do this. So these are the policies that I just created. I just created a sender over here and receiver, and this is basically the keys. You have to select what policy, and then there's two keys, right? You can copy that from using these buttons. So what I'm going to do is I'm going to copy those keys into my Notepad application. So this is for the sender, because I'm going to need those later.
Why have two keys?
Because one is used by the producer, right? The application that produces events, it needs the credentials to send the messages. And another key is for the application that on the read side, reading messages from the queue.
I think you can also need one key, both for the receiving and the sending.
You could, but you probably don't want to put your shared access key on every device.
Yeah.
It's out there somewhere.
Right. Now we go to Visual Studio, and I already have, basically it's a regular .NET Console application. The only thing I did here is that I went to the NuGet and I installed a couple packages over here. So I installed the Azure Service Bus Event Processor host, right? And I also installed, while it installs the event processor host, it also installs the service bus and the storage assemblies. And so for our program class, I'm going to just paste in some of the code here, and let's go through the code. So the first part of the code is basically reading some of the configuration settings from the config file, and there's two kinds of configuration settings. One for Event Hub itself, and the second one is for the storage. And the storage is used by the event processor host to kind of to work with this. What's the word I'm looking? To work with the distribution of different partition to different threads. Basically, what event processor host does, it creates the number of threads that's equal to the amount of the partitions in the hub. And then the way it assigns the thread to the partition, it basically creates this kind of like a game and tries to get the leads. It creates a number of blobs on a storage account, and then it tries to get the leads on those blobs. Whichever thread gets the least basically receives this the access to this particular partition in Event Hub. So we can read it more about this stuff on the Microsoft website. And the second part is where I create the instance of event processor host, right? So there are several parameters I have to pass. So this is a name. This is the name of the event processor host. It doesn't really, I don't really know what it's used for. So I just basically get a new GUID and I just convert it to string and pass it as a name. So it just has to be unique, I guess. And three parameters for the event hub, right? So actually for the event hub and for the storage. Actually, in this example, I'm using the default consumer group. So we created the console reader consumer group, but we're going to use it later. And two connection strings, one for the event hub itself, and one for the storage to basically play the game of selecting the right thread for the right partition. After I done created the event processor host. This is the wrong place. I'm gonna call the register event processor async, and I'm gonna pass in the type parameter, which is basically the name of the class that I want to use as event processor. And it's in red because I don't have this class yet, so let's just create this one, right? So we're gonna click and say generate this class in a new file. Let's open the new file, and over here I'm gonna replace this with my implementation that I have prepared. So I'm gonna import some types here. Hopefully it's all results. So the iEvent processor interface implements three methods: open-async, close-async, and process event async. So open-async, when the instance of this class gets assigned to process events, that's when the event processor host calls this method, and it passes in the partition context instance, which basically has some information about what partition are we going to do reading from, right? The close async is opposite. When the partition, when the instance gets shut down by the event processor host, it calls this close async. And the most useful from those three is actually process events async. And so what's so it's asynchronous method, and you see that in parameters, again, I receive the partition context information about what partition we're going to read from, right? And it's also, the IEnumerable of event data, which is basically just, serialized, rather deserialized events that the event processor host read from the event hub and kind of, feed to us to our method to process. And then I just have to implement this for each event loop and read the data, and basically I just gonna spit it into the console one by one. There's stuff that happens with checkpoints, but you can read about this online. I'm not gonna talk about this, a little bit too complicated. One more thing that I want to do is I want to go to my config file and paste in some parameters for the configuration strings. Okay, and that's where I'm gonna need my values from the from my notepad. So I'm going to use this is a reader, so this is a receiver. I'm going to need a receiver key, and I'm going to paste it into the connection string. So this is a receiver, this is the connection string. Now let me make sure that the name of the event hub matches. So this is actually supposed to be MoDev. Okay. And I think we're good to go. So I'm going to build and I'm going to run this application. And it's going to run the console up, and it's going to display that, it created. No, it didn't. What happened? What is going on?
Did you paste both strings in?
What?
Did you need to paste both strings in? There's two strings in there.
No, this is a receiving application, so I just
need a receiver string. Okay.
Hold on a second. What's going on? Oh, you know what? I probably messed up the account, the storage account. Yes. So I'm gonna need to go to my dashboard on new portal and copy the key for the account. So I already done this presentation for our local in-house kind of group, but I didn't do. I'm gonna copy the key. Right, hopefully when I start it right now, it should just open the console application. It doesn't. Storage account. Right, I think we're gonna move on, and we'll try. I'll try to run one from the complete solution that I have ready. So I have one more chance to do this right. So MoDev event hub live. Event hub. I'm gonna need a reader key. Receiver.
Now, is what you're building now is the script that you're gonna load onto the Pi?
No, this is just a console application to read the messages, and on the Pi, we're gonna build a script to send the messages. So I just wanna build something to read first, so that when we actually start sending, you will see that the messages get received on the other side.
And then you're connecting this console to the Event Hub in Azure.
Exactly.
Okay.
Yes. Yes. All right. Let's try to do this.
Wouldn't be a live demo if there wasn't a snafu. It's par for the course.
Okay. Here we go.
There you go.
So basically, it initialized two instances of my event processor class, right? And it assigned them different partitions, partition 1 and partition 0. Right now, now we're gonna go to the Raspberry Pi, and we're gonna paste in the connection information to the little Python script. Right. So to do this, I'm gonna use my my trusty FTP client. And hopefully everything works out. So again, I'm gonna copy the sender. This time it's gonna be a sender credential. I'm gonna paste it into the, and I'm gonna have to change the name because this is a live instance of the event hub. I'm gonna save it. I'm gonna upload it to the Raspberry Pi. Now I'm gonna go. This is a SSH console that's connected to the Raspberry Pi, and so I have the Azure. This is the same file that I just edited. This is the same file that I just edited. So Azure Event Hub demo, and this is Azure Event Hub demo Python. So I'm gonna do a sudo python 3 command, and I'm gonna use this script that I just updated with the new credentials. And see, it started to send data, and we already see that we're receiving the data on our receiving console.
Wow.
And it works almost instantaneously, so there is a sub-second delay between the messages being sent to the cloud and received to the cloud.
If you disconnect the client and connect the gen, you will receive only the live events or the rest of it?
Yeah, when you create a client, there's actually an option to specify where you want to start. You can either specify a very particular timestamp, or you can specify the ID. So there's several options to do this.
Now, what kind of sensor do you have on here? Is it a sound sensor? Or?
No, it's basically there it is. So it's a temperature and humidity.
Okay, cool.
Yes.
So this is HTTPS or AMQP. Can you do UDP?
No.
You know? No.
And I think they did it for the. I mean, they want people to use AMQP, but because they want to be they don't want to build like any predicament, so the people start using it everywhere. So they support HTTPS. So basically, wherever you can send a HTTPS request, you can use the event hub in terms of sending capacity, right? So I mean, Raspberry Pi is more than capable of sending HTTP requests. Okay, and this is our first demo. So I'm just gonna, have this guy keep sending the messages, but I'm gonna stop this guy over here. And let's go back to our slides. And I'm gonna go where we stopped. So now let's talk about actually the processing engine that's behind it. So now we set the stage, so we can generate events and we can read events from the let's say from some console application or service application that are going to run as a payload on our cloud service. But we want something a little bit more advanced, right? So we don't want just the messages that we send in. We want the messages get processed, right? So. And that's why that's where Azure Stream Analytic services comes in. So it's basically another completely managed service that's hosted in Azure Cloud, and from the ground up built for hyperscale. So it can process hundreds and thousands and millions of events. It has some really nice features in terms of real-time process. So it has some temporal features in the query languages. We're going to talk a little bit later. And as I said, the developer productivity great because it's basically like tries to piggyback on the regular T-SQL language. So if you take the language itself, you'll be amazed how close it looks to the SQL. And it's very cost effective. So running a single instance of the Stream Analytics again costs about $15 a month. Of course, you take into account all the traffic that you want to pass through, but just to play, you can instantiate the instance of the Stream Analytics job for like $15 a month. Right. So when we talk about the Stream Analytics or any stream processing, we talk in terms of job topology. Right, so this is a very typical job topology. Sometimes it's called Lambda architecture, but essentially what you have a number of inputs. There's two types of inputs that you can create in a Stream Analytics service. So it's either streaming data, right? So usually it's Event Hub, and you can have reference data. Think about the reference data as a lookup table in your database, right? So right now it only supports blob storage for the reference data, but they work in the future to introduce like SQL tables and more. And on the other side, right, so the data gets processed, and where do you put it, right? So there's a number of options right there, and we're actually going to go through. So the inputs again, the data streams and the reference data support three formats right now: JSON, CSV, and Apache Avro, which is a binary JSON, which is much more efficient, by the way. And as for the outputs, you can either use Azure tables to just dump your raw data. SQL database, event hubs. So this is a great feature where you can like chain those jobs in your pipeline, right? So you can grab from the event hub, process, do some aggregation, throw it in another event hub. The next job is going to pick up those processed data aggregated with something else. And this is how the Lambda architecture looks like. So basically you have single input, multiple outputs, and then from multiple output can aggregate again on a single output. Also supports the Power BI dataset and DocumentDB. And this is some of the language constructs. So if you take a look at the left column over here, so you can do selects, you can do selects from, you could use where, grow by clause, having, very similar to your vanilla T-SQL language, right? But in addition, it has a very great temporal semantics. So we can use things like when you group data, right? So the difference from the database and the difference between the database query and the Stream Analytics query is that when you run a query in a database, it runs on a finite amount of data. Basically, the database locks the number of records in a table, right? Executes the query and gives you the output based on this locked amount of data. But in the streaming world, the data keeps coming, right? How do you deal with this, right? So they introduced the concept of windows, and there is three types of windows. So when you group the data in a particular window, right? So three types of windows. First type is called tumbling window, and this is a fixed length window, and actually they're all fixed lengths. Let's say, in this example, you have a 10-minute fixed window, and it starts from the top of the hour, and every 10 minutes, the Stream Analytics is going to create a new window for you, and events that fall into this window are going to be aggregated based on this time interval over here. Make sense? So every 10 minutes, you're going to have a new window and then from the top of the hour again it starts over. So hopping window is similar to the tumbling window, but it has this little overlap. So it's still the 10 minutes window, but instead of starting at the 10 minutes, it's going to be staggered 5 minutes apart. Right? So there's going to be some overlap, and so the messages from this overlap is going to end up in both first window and second window. Okay. And the last one is the craziest one. It's actually a sliding window. So in a sliding window, basically you have a window that tries to accommodate any number of particular variants of your messages, right? So you have a 10-minute window, and it basically constantly slides. But then if somebody of you have a physics background, they think, how is this possible, right? The time is not discrete. You can have an infinite amount of those windows, right? How the system manages this? Well, if you think about it, it's very easy. So while the time is not discrete, your events are pretty much discrete, right? You have an infinite amount of, finite amount of events that you go through the system, right? And so for any number of events, you can always say, hey, this number of events fit into this 10-minute window. Basically, system analyzes this window based on the incoming events into the system.
Does it generate, depending on which window you use, is it doing a window for each separate Raspberry Pi event generator? Or is it aggregating it, or is that all in how you design it?
No, it does. No, it does it for all the events, and then you group by based on this window and some other criteria.
Okay, so all the data from 3 different Pis would come in,
Yes.
be amalgamated, and then these windows.
But you can group by window and by device, and then it's going to group it for each device.
Okay, okay.
It depends on the grouping condition, whatever grouping condition you're going to
Got
create.
it.
So how does it work? I have a query in this advanced SQL or different SQL language. Am I supposed to run this query multiple times, or do I just define the query once? In my query, I say which type of the window I want to use. That data is aggregated, pre-calculated, stored somewhere, and then every time my dashboard or some other view looks at that data, it is already pre-calculated and stored.
Yes, it's basically a query that never dies. It's going to keep, running over and over again with the different windowing parameters. So the window is going to get renewed, and the query is going to keep running.
And essentially, with the sliding window, that query actually, I don't know, I can't.
It's going to keep running, but on undetermined undetermined points in time. Whenever it feels like this is the point that I can actually do the window, it's going to run. It's the craziest one. It's not recommended to use, but we're actually going to run the scenario today and try to use it.
So this will be re-evaluation at the moment when I look at the dashboard, for example, or when I look somewhere.
No. The system going to evaluate the window when the event is coming into the system. Into the system.
So would you use a sliding window, say, if you wanted to get a new interval every 1,000 events or whatever?
Well, for example, we're going to use today. We're going to try to see if the temperature is rising too rapidly. Let's say we have 1 minute window, and we see if the temperature jumps like 5 degrees in this minute. So that we see that something is going on critical, and we have to take some measures.
You could use a sliding window to capture sessions of a user. The session can happen for an extended period of time, right?
So the receiver was an async that took a collection of events. So I was wondering at the time, how is it determining which collection of events to bundle up and pass along when it's calling that event? It's async, right? So I was does it correspond to a window, or how is there a formula? Or maybe I saw it wrong, but I thought it was saying you can get a collection of events per call to the receiver async. Is that right? I can be wrong.
There is no receivers. I mean, there's basically it's a service, right? So it's
This is back on the code you were writing.
No, it has nothing to do with the code. So basically think about it as a completely different thing.
Okay.
So it's kind of like our console application, but it's only console application from the incoming side. Whatever happens after we get those events, it's completely different.
Right.
And I'm not even sure that they use this event processor host in their own implementation of handling those messages, because they do accommodate multiple multiple number of data sources from the inputs. It's not just event hubs. It could be reference data.
Question: the emitting semantics for this will only emit the results after the processing is complete throughout the entire window, or
Yes.
does it emit?
Yes, after the events complete through the entire window. There's actually, if you use the window in your processing, you will see that there is like a delay on the output, which is basically equals to the width to the span of this window.
So it would handle like out of order semantics or?
Yes, definitely, it handles out of order semantics.
Well, at the cost of having to.
And you can specify what order you want to receive the events. Either it's the time when events was thrown into the system, or something in the payload. So you can say this field in my payload should determine what placement in the overall order should it take. Yeah.
So if we take the first example, the standard window. So I start my query that this window of 10 minutes. It means that my query will run forever, and it will produce me some results every 10 minutes?
Every 10 minutes. Alright guys, let's moving because we kind of hit a later time. So now we're gonna have a really quick demo when we're gonna create Stream Analytic job on the portal, give it some input, some outputs, and write a simple query. Right? So let's do this. So I'm going to go to the new portal, and I'm going to close this dashboard, and I'm going to create a new Stream Analytics job. And when you create a new job, you have to provide basically a name, and it's really at this point it doesn't matter. So let's call it MoDev Live. I'm going to use existing resource group, so it supports, resource group deployment model, so you can actually script it using the resource group templates, and I'm going to place it in the same region where all the rest of my artifacts are. So I'm going to take maybe less than a minute to create the group, to create a job, hopefully. Okay. So the job is created. I'm going to refresh my console, and this is a resource group. This Windows resource group, and so this is my newly created Stream Analytics job. So I don't know if you can see. Let me show you. So basically, this is the topology that I was showing you before in the picture, right? So you can create a number of inputs, right? You can create a number of outputs, and you can kind of link them together with your query. Right? So let's go ahead and create an input, and for the input we're going to use this event hub that we just created, right? And let's call it input. So not really creative, but this is a data stream, this event hub, and this event hub from the same subscription. So it kind of do a nice thing of populating the lookup values of these drop downs. So from my MoDev namespace, and I'm going to use this MoDev Live event hub. So I'm going to use a receive policy because this is the event hub that I'm going to reading from, right? So I need this receive credential to read the events from this event hub. But what's nice, it's actually auto-populating me the choice from the available credentials in the event hub, right? If it would be in different subscriptions, I would have to, there would be a field to manually paste this key into the properties of this event hub, of this input. Make sense? And for the consumer group, I'm just going to use the default consumer group. So we just created an input, and I don't know if you can guys see, but it's actually when it creates the input, it automatically tests if the connectivity properties are correct. So successful connection to test. Now you see we have one input. Right now we're going to create a couple outputs. So for the outputs we're going to use Azure tables. I already created those tables in my storage account. So I'm just going to quickly connect two tables. So we're going to use two outputs. The first output is for the raw data. So basically as the data comes into the service, we're going to store it as it is. And the second table, we're going to store aggregated data. And we're going to aggregate it, I think, on a tumbling window of like 1 minute. Every 1 minute we're going to aggregate the data and see the average temperature during this minute. So the first one is called raw data, and this is going to be Azure table in my account, and the table name in my account, and the table name is going to be raw data live. So for the partition, if you guys worked with the table storage before, it's basically Azure storage table is a big hash table. So it's hash table of hash tables actually. So you have to specify the ID of the partition and then the row of the partition of the row key, ID of the row key to store the data. And this way it basically very fast. It gets very fast to access this data and to save this data, but very slow to delete the data. So basically this table designed to store the data and read from it, but updates are really slow. And so we're going to use the device ID as a partition key, and for the row key we're going to use timestamp. We're going to create and we're going to start creating the second one. And the second one we're going to call output, and this is where we're going to store aggregated values. So again, it's going to be Azure table. It's going to be in our MoDev storage account, and this is going to be temp average live. Again, device ID is going to be our partition key, and timestamp is going to be our row key. Alright, so while it's creating the second output, we're gonna start working on our query. So I'm gonna go back to my Visual Studio, and I have a query over here in my snippet. So let's take a look how the query looks. So because we're gonna have two outputs, we're gonna basically create a query of two queries, and that's a great thing about the way how you create a job is you can. For each output, you can create its own subquery, right? So it's really not complicated. So basically, we're going to select the events from our input, right? We're going to timestamp it by the data in the payload. So when we send the events, we send this field origin UTC when the event was created on the Raspberry Pi, and that's how we're going to timestamp, not by the time how they enter into the Stream Analytics, but by the payload in the event itself, right? And I'm gonna send this data into the raw data table without any aggregation. So I'm just basically taking the data and throwing them into the table. Well, the second query is a little bit more sophisticated, right? So this time I'm still gonna read from the input. I'm gonna timestamp my events by the data on the payload. But this time I'm going to group it. I'm going to group it by two fields. I'm going to group it by device ID, and I'm going to group it by the tumbling window of 1 minute. So essentially for every device, for every minute, I'm going to aggregate the data and calculate some aggregates over here. So I'm going to calculate aggregated temperature and aggregated humidity for the minute for every device.
So this tumbling window is, it's not the name field. This is window which you want to use. It's not this window. How does it know to which field to apply this annotation?
It's going to apply to all the events.
But if, for example, I have 2 timestamps, there in my record? How does it know that it needs to do it by my timestamp?
That's because I specified the timestamp this input by this field.
It's a different table. It's the same field going into two different tables. Yeah.
So the event in its payload has this field called origin UTC, right, which is a timestamp when the event was generated. And I'm going to use the value of this field to determine the order of the events in my processing engine.
So in the prompt clause, I'm specifying that specific field which
Yes.
will be used
Yes.
for my vendors.
Exactly.
Okay.
And if you have multiple inputs, you can actually specify the timestamp for every input.
No, I don't think I have multiple timestamps.
Well, it's your business decision which timestamp do you really want to work on, right?
Okay.
Okay, so I'm gonna copy those two queries and I'm gonna paste them in a job, and I hope, yes, both outputs were created, so I'm just gonna paste them in a query. I have raw data in the first one, I have output on the second one, and hopefully this all gonna works. It's saving, it saved it, and I'm gonna run it. But before I run it, I want to open a little console over here, right? So this is a custom written console application. Console web application. It's ASP.NET MVC app that on the back end there is an API that reads the data from the table, and the JavaScript gets the data and plots it on a chart, and it refreshes the chart every few seconds, right? So you can see that it refreshes the chart, but there is no data coming from this sensor, right? So we're just gonna launch our query. And remember, somebody actually asked the question when you read the events from the hub, where do you start reading, right? So there's two options right now. You either start reading from this particular point in time, or you can create some custom timestamp, right? And if I would run this query before and I would stop it, I would have a third option actually to resume reading the events from the time I stopped my query last time. So basically, there is a very good scenario for not losing any data even if you stop your job.
The next question is, we have 1 day window. And what happens when you come back, like on Monday, with data and press resume?
It's going to process this data.
All available.
Well, if it depends on the retention policy for your event hub. I mean,
yeah, but we define it as 1 day, and now we're coming back 2 days later. You will just complain saying that there is a gap. Or
it will try to read it with a timestamp 2 days ago, but there will be no data with timestamp 2 days ago. So it's just start from whatever was left today. It's usually taking a couple of minutes to spin up the job, and yes, maybe we have some questions. That's a great time to ask questions.
You have 2 SQL statements. There was no terminator between them. Does it just know?
No terminator required. That's on purpose. Yes. And you can actually do. You can kind of do. You can do with. I think in SQL it's called CT.
Common table expression, right?
Yeah, common table expression, CTE, right? So you can do the similar thing in ASA queries. So basically, you can say, hey, from this input, pre-aggregate me some data, or you can massage it before you actually do some real query, and then you can aggregate the data from your CTE and then process it. Okay. So another way actually to check if something is being produced in this job is to go directly to the table and see if we have any data on the table. And of course, I don't have my tables over here.
So in this example, if you define a custom timestamp to partition into windows,
the only thing for Stream Analytics is to recognize that the previous Windows is finished, is to
Oops.
receive the event with
See?
a new window, right?
See, we have the data coming. I'm sorry, I missed
Yeah.
you. I was so excited that actually it's working.
So if we're defining the window by the custom timestamp value in our input, the only thing for Stream Analytics to recognize that the previous window was closed is to get the value from the next window.
No. The temporal aspect of the query is actually quite complicated. This is where basically the similarities between the T-SQL and the Stream Analytics stops. I mean, it's really, you have to like wrap your head around this. It took me several months to figure this out. So apparently there are actually three timelines. There is three timelines that goes into the Stream Analytics job, right? So there is a timeline when the events enters the system, there's a timelines when the event's supposed to be processed, and then there's another timeline when the event's supposed to be output. And so there's a very complex orchestration that goes behind the scene. And in addition to this, you have another level of complexity by introducing the partitioning, because you have the data coming from multiple sources. If you don't think about this up front, you can get yourself in a really like unoptimized solution. Yeah, I use a really cheap temperature sensors.
I just said the sensors are always,
But
there's only cheap ones, I think.
This is only 0.1 difference in the temperature. This is the temperature degree. So C the lowest is 27.1. So it's just a scale on a vertical axis, right? And also, this is a raw data, but we can also look at the aggregate data by the minute. And there's going to be only 3 minutes right now. So we're only running for 3 minutes, and so we only have three points. This means that aggregation is actually working.
Should we hold it for a while? See if...
Oh, you can like I don't know, blow it or just be careful, don't disconnect it. Yeah. We're actually going to look at this a little bit later. So if you hold your breath for like 5 minutes, we're going to have a real example of something.
I'm not going to hold my breath for 5 minutes.
If you hold your breath for 5 minutes, you won't be asking any more questions. No more questions.
All right, unless you guys have any questions regarding this technical stuff, we're going to move to the fun part because we kind of ran out of time. All right? Okay, so let's go back to our slides, and so I'm gonna do this. So this I'm gonna do extend. So do you guys watch this series? Mr. Robot. Actually, the second season is coming, I think, this summer or this fall. It's really, I think it's like the best series about programmers doing some hacking. So they show like real code examples. So the story that goes basically like through several episodes, that the group of hackers wants to hack a big corporation. So they want to encrypt all the data because it's a very, very bad corporation. So they want to encrypt all the data on all the hard drives, but then there is a problem because it's a really big corporation. They do actually backup stuff, right? They backup their data into the facility called Iron Mountain. And so even if they encrypt all the data on all the hard drives, the corporation can still restore the data from the backup, and basically all their hacking, is in vain, right? Because it doesn't make much sense. And so what they decide to do is they decide to hack into the Iron Mountain facility, hijack the AC system, turn the heaters on to the degree when all the backup tapes actually melt. Right?
So it's kind of like Stuxnet.
Right. So this is actually, I don't know, you can say about, it's a bad, it's what's it, black hackers or white hackers. So, but this guy actually wears a hoodie, and what's the funny part is our company is presented, those hoodies to every employee in our company for the Christmas last year. And so I'm kind of I'm gonna try to wear actually two hats. I'm gonna try to wear the dark hat, and I'm gonna try to. Well, let's think. We are here in Iron Mountain, right? So our facility is Iron Mountain. So I'm gonna play the role of a bad hacker, try to hack into the Iron Mountain. I'm gonna try the role of a good hacker, trying to kind of protect our Iron Mountain from consequences of hijacking the AC system. All right. And so essentially we're gonna run some demo, and in this demo, what we're gonna do is we're gonna create a simple console application that's gonna read the events from the event hub that's called circuit breaker. So as soon as event enters this event hub, that means something really bad happens in my system, and there's some parameters where I have to pull my circuit breaker on this particular circuit, right? And so I'm going to have a stream analytics job that basically analyzing the data from the sensors, right? So I have 3 sensors right now, and so it analyzes the data from the sensor. It sees if the temperature rises more than, more than. You guys, you don't see it. Sorry. Let me go into the duplicate mode. So if the temperature rises more than 3 degrees in a single minute, that something is wrong with this particular AC control, and I'm going to shut down the power to this circuit to prevent fire hazard. All right. So let's do this. So let's take a look at our I actually have already running I already have the stream analytics jobs running, and this is I think this is this one. So it has 3 queries. It has 3 queries. The first 2 queries is it's absolutely the same that we just ran, right? So basically store the raw data and calculate the average temperature on a 1-minute window for every device, right? And the third query is the one where I want to see if for any particular device in a sliding window of 1 minute I have the difference between the max temperature and the minimum temperature more than 3 degrees. If this condition meets, I'm gonna output an event to the circuit breaker, and the circuit breaker is just an event hub on the other side. It's basically a third output to the job that runs as the previous job, but with an additional part of the query. Okay, and so in my solution, I have a small application called circuit breaker, and it's essentially the same application that we went through in the beginning of this presentation. So it's console application that reads the data from the circuit breaker event hub, right? And if it sees that from this particular sensor, right, came the event in the last 5 minutes. So we're gonna call some magic function called circuit breaker async. I don't know if you can see this, guys, but so if we need to call circuit breaker, just call this magic function call circuit breaker. All right. I'm gonna run this just in case, so it we clear some of the residue again, because I've been preparing to this to this presentation for the last few days, and I've been using the fan to raise the temperature, and I actually melted the sensor. It's actually in a different floor, but so the sensor now gives me unreliable temperature data. Sometimes I guess false.
You mean in the Pi? You fooled with a fan?
Yeah. Yeah, okay. I was just basically like trying to see if it's really going to trigger some events when I raise the temperature.
Ah, so you put like a hairdryer or something
hair dryer,
like that.
Yes.
Yeah, okay.
Yes, okay. So we good? And
so we're talking this office. The device is here, so if in the case of fire hazard, we're all in danger.
Okay.
So that you know.
The door's right there, so I feel okay.
No, there was.
It's raining outside.
Yeah.
I'm actually gonna switch to the console, and this is the sensor that we're gonna look at. And you can see, the sensor is really crappy right now because it gives me like this these shootouts to the lower temperature, and this is really gonna screw. It has a big potential to screw my experiment over here. But let's hope, right? So let's hope. So we're gonna now I'm gonna wear like the bad hacker persona, right? And I'm gonna hack into the AC system. Yeah, and I already been to the facility and I plugged in my Raspberry Pi into the AC control panel. Very discreet. But so how do you hack into the Raspberry? I mean, how do you log into the Raspberry Pi? Basically, you just use SSH, and you SSH. So I know the IP address. Okay. And how can log in? Because nobody changes the password on their Raspberry Pis ever. So, so I'm just gonna log into my Raspberry Pi, and there you go. And I'm gonna go to my secret directory, which is I think it's desktop. Where am I? Okay, so scripts. Yes. And the script name is actually, the script name is very complicated. It's really hackery. 3x. It's exploits. See? And now I'm gonna run my exploit. Okay. So let me set the stage. So this is my hacker script. This is my chart, right? So let's run the circuit breaker application, and hopefully it's not going to catch any false positives. And it did, so I'm going to have to rerun it again. Sorry about that. Don't use cheap sensors, for your demonstrations.
Could you maybe
All right, so it's in a different.
use the
all right.
threshold?
So I ran my exploit. Now all the AC turned on to the heat. And if it's so, you will see that the temperature is going to start rising. The temperature is going to start rising, and hopefully my little circuit breaker will catch when the temperature is going to rise for more than 3 degrees in a single minute. I know it doesn't look like much, but believe me, see,
There it goes.
the temperature is rising, so we're going to burn this mountain. Gonna burn this mountain. Now I need to catch, there you go. You see, guys, this? Over here. Detected anomaly on EBT3. So this is basically detected that, we have some anomaly, and we issued a circuit breaker command, and hopefully if we hold on for a couple of minutes, you will see the temperature will start dropping. I think this is some residue because we aggregate by 1 minute.
Yeah.
So it's maybe we need to wait.
But wouldn't the temperature just stop, not decline?
It's going to start declining because there is an ambient air in it, so it's going to start declining.
Okay, but you've turned, theoretically in your scenario, you've turned the machine off, the Pi off.
No, I turned the hazard off. I turned the power to the heater.
Oh, okay.
And this is if anybody remember the overall architecture of the solution. This was there was a small thing, send event back to the device in the very right low corner. So this is basically this scenario when you get information from device, do some analytics, and then you get an insight, hey, something happened, maybe I need to talk back to this device, and then you route this event back to the device and say, do something about it, right? Maybe shut down this device, so apply some some corrections, and you can see the temperature is slowly leveling out. So and there you go. I hope you liked it, and if you have any questions, just feel free to stay and yes.
So let's say that I run this query and it produces me results on a regular basis, some aggregated results. Can I use results of this query as another device for the event hub?
You can send it to another event hub, and then use this event hub as an entry, as a source for another job. And this job might be, receiving the results from multiple applications. Does it make sense? Yeah.
I mean, like, I have devices connected to the event hub,
right,
that register some events. Then I have this analytical query that running on top aggregating, and I want to connect it back as another device. Can I do that?
Well, essentially, yeah. Nothing prevents you, I guess, from setting the same event hub as an input and an output. But I don't know.
I think you can
aggregate
this. You can aggregate this query into a string representing JSON and send it to the notification hub. There's the extreme scenario because it's hard to maintain building a string within a query. You might want to use some.
So we have a query that aggregated and put in a table. We also then have a query that just triggers some additional event based on the same result.
You totally can.
You calculate it twice. If you can connect it back, then it's calculated only once and send it back in, so I can read it as and trigger some events based on that.
If you could, if you could make a correct MIME type, you can send it into the notification hub to all of your devices or to some of your devices. But this is not a very common scenario because you'll be responsible for creating the correct the type that the notification hub expects.
Well, but you could structure it the way that it looks exactly as its original message. I mean, no, I think you totally can. I mean, the big question is why would you want to do this? To recycle the same, essentially same information over and over.
If it is aggregated, I don't need to calculate it twice. If I want to store it in a table and produce some dashboards separately, like streaming, not taking it from the table.
But you can just have multiple queries and stream it to different outputs.
Will they be all calculated, or it will be calculated once and produced more?
Yeah, you can use. Remember, I talked about those CTEs, like those like pre-aggregates. You can pre-aggregate the results and then output it into multiple.
But CTE give me some, like it's basically converted something from the select from. We can consider it part of the select from, but then you have a separate query. It's independent from the first one, right? Or they all connected?
Let me show you some of the queries that we actually have running on some of the systems in our. So you can do things like this. You can say with. Oh, I'm sorry. Let me duplicate. So you can do things like this. So you can say. In this query, what we do is actually we have a single event coming into the event hub. This is actually some coordinates from the vehicles, right? And I want to calculate speed, how fast the vehicle is moving. So what I'm doing is actually I'm picking back into the stream and saying, hey, give me the first nearest point to the past, right? And so I'm looking for those intervals. And then I said, hey, those are the intervals, and now do me calculation of the speed and also store me the original intervals. And then once you have this width, right, then you can have multiple widths. So you see this, there is the intervals, there is the results, and then at the end, you can say, hey, select, from this over here and from this select,
This this thing is actually very clever. It's gonna determine that you have partitions. It's gonna determine the queries that you have, the subqueries, and it's gonna, if you configure it to run on multiple instances, it's gonna run on multiple instances, like the nodes that will calculate. It's pretty much like the neural network, apart from learning. So it's like the learned neural network.
Yeah, it's actually it's a very complicated technology behind the scene, and like if you want to seriously look into this stuff, like you will really need to read on partitioning. So you can partition inputs, you can partition outputs, and you can also partition your queries. And then when you partition all three of those things, you will have the best optimized topology of the whole job. And this is really like it's a complex. I mean, they make it look like it's very simple. Hey, just write those selects and aggregates, and you're gonna be fine. But like when you start receiving lots of incoming information and you don't partition it correctly, it's really just basically blows the job. I mean, the job just freezes and stops producing any results. We've been over this many times.
Just thinking out loud, in terms of the topology or the architecture of the setup that you've got, could you, the trigger that went, motivated the circuit breaker, could that actually be built into the JavaScript on the Graph website? In other words, when that's pretty simple if then. If go jumps 3 degrees, you've got you're ingesting the data.
I don't know if there's SDK for the JavaScript to receive to receive the messages. I'm pretty sure there is SDK for the node to send the messages into the event hub. I don't know if there is like something like event processor host for the JavaScript that you can basically just create like a JavaScript event reader. So I'm not sure about this part.
Yeah, I think you'll have to implement something like the web service with SignalR that will trigger something on the client.
The only reason I would think that would be like in your story scenario, which was great, you did a great job with it. I would almost want to sort of diversify the portfolio of steps. In other words, if any one step failed, the other would sort of independently would be triggered independently.
Well, you almost always, when developing solutions in these kinds of problems, you always have some development time, debug, source receivers, and you always have more than one source.
Just redundancy.
Yeah, during the development, just to see how the thing works.
By the way, this is a great feature of the event hubs, these consumer groups. You can have the same events and you can read them over and over by just creating a new consumer group.
Okay.
So you can create actual production system, you can create logging system, you can create like archiving system, and all basically acting and playing on the same event hub.
Right. Okay. Great.
Right. Thank you very much for coming.
Fantastic.